Hello guys, and welcome back to my YouTube channel. In our previous video we write this code for selection sort in C++, and then we run this code and see a successful execution of selection sort. Now we will see the time and space complexity of selection sort algorithm. So the time complexity of selection sort algorithm is O(n) square, as there are two nested loops. One loop to select an element of array to be array one by one, so it has a time complexity of omega n, and then we run another loop which was actually the nested loop inside of our first loop to compare that element with every other array element, so it has a time complexity of omega n 2. Therefore the overall time complexity for our selection sort algorithm will be omega n square, and space complexity will be omega 1, as the only extra memory used is for temporary variables while swapping two values in array. The selection sort never make more than omega n swaps and can be useful when memory write is a costly operation. So we have done our selection sort algorithm. Now we will see our bubble sort algorithm. Bubble sort is the simplest sorting algorithm that works by repeatedly swapping the adjacent element if they are in wrong order. This algorithm is not suitable for the large data set as its average and the worst time complexity is quite high. So it is recommended when we are working with smaller data set. So let's take a look how does the bubble sort actually works. So let's say we have this array of 5 integer having element in randomly sorting order 5, 1, 4, 2, 8. So let's see how this bubble sort will sort this unsorted array. So in the first pass, bubble sort start with every two elements, compare them to check which one is greater. So in our this array, first it will take these first two element 5 and 1 and will check which one is greater. Here the algorithm compares the first two element and swap them. As 5 is greater, so it will come to right and 1 will come to the left. Then in the second swap it will take next two element and check. So as 5 is greater than 4 2, then it will again swap 5 with 4. Then it will take next 2, which is 5 2. Now it will swap it also because 5 is greater, and then it will take last 2. Now it will not swap because 8 is greater than 5. So that's what will happen in our first pass. Now for the second pass, it will again take these two elements and check it. Then it will go to the next two element, check if a swap is needed, then it will swap them, then our next two elements, and then again last two elements. So in our third pass the array is already sorted, but our algorithm doesn't know if it is completed, so the algorithm need one whole pass without any swap to know it is sorted. So it will try it again by first two, then second two, then third two, and then the last two. So now this time there is no swap involved, so our algorithm knows that our array is now sorted. So it take at least one no swap to know that array is sorted. So this is how our code will work. I have illustrated this. So first I will is equal to 0, and then j for I is equal to 0, it will do the j for the sixth time, and same goes for I is equal to 1, it will do it for 5 times, and then 4 times, and then it will do it 3 times, then 4 times, then 3 times, then 2 times, and then 1. So now we will take a look at code example, and we will implement this bubble sort algorithm in C++. So this is our code for selection sort algorithm. I will just simply delete it from here. Now it's time for the code of our selection bubble sort algorithm. So I will write our bubble sort function, void bubble sort. It will accept 2 parameter. First one will be the array, and second one will be the size of array. Now inside of it I will define 2 variable, I and j, for our loops. Now our parent loop I less than n minus 1, and then I plus plus. Now our child loop for j is equal to 0, and then j is less than n minus 1, and then j plus plus. Now inside of it we will check if jth index of our array is greater than jth plus 1 index. Then it will simply call the swap function, and it will pass the jth index of array and j plus 1th index of our array. Let's quickly type our swap function. yp is equal to our xp, and yp is equal to our temp. So after this swap function, let me type our print function. time for our main driver code. I will initialize an array of integer and give it value of 5, 1, 4, 2, 8, and then our size will be n. Now I will call our bubble sort algorithm which we just made and pass it our array and the size of our array. Now I will just print the sorted array. Now I will call our print function. So our code for bubble sort array is complete and ready to test. So let's test it out. Let me delete the previous compilation and run it again. So you can see our array is now sorted, but one thing you must have noted, that is it is taking more time as compared to our selection sort array. That's because it is doing too much comparison and swapping in each iteration. As we go back to our code, so we can see first we have this parent loop, and inside of this parent loop we have our child loop, which will run as many time as our parent loop, and inside of it we are comparing the two elements. So in the first iteration we will compare first two element. In this case it will be the j and j plus 1, first and second index, and then if it is greater than the second one, then we will call the swap, and again now our j is 1, so now we are comparing first and second index. I just make this arrangement so you can see a clear picture of that. So yeah, at the first iteration we were at this, and then at the second iteration our j become 1 and our j plus 1 become 2, so it will compare these two, and after that our j will become 2, so it will be here, and j plus 1 will be this, and then it will compare these two, and after that our j will become this 0, 1, 2 and third index, and j plus 1 will be the last index, so it will compare that. And after the completion of this child loop, it will again go back to the parent loop, and this time our I will be the 1, so it will start the loop from this. So after the successful first iteration of our child loop, our parent loop will come into this second phase, and this sorting will be going on like this until all the elements are sorted in the array. So now let's check the time complexity and space complexity of bubble sort algorithm. So the time complexity of bubble sort algorithm is log n square, and space complexity is omega 1. So that's all from today's tutorial. Thanks for watching. Hello guys, and welcome back to my YouTube channel. In our previous video we start the topic of merge sort algorithm. We see how we can implement merge sort algorithms, and then take a look at actual algorithm which we then later use to implement merge sort algorithm in C++. We successfully created our function of merge sort, and then we start to build our merge function. So now I will continue this video where I left our last video, or ends our last video. So we have create our first loop for copying data of temp arrays, left and right array, temporary array. Now first loop is created. Now I will create our second loop for auto I is equal auto j is equal to 0 and j is less than sub array 2, and then j plus plus. Now for the right temporary array, jth index is equal to array mid plus 1 plus j. Now for the index of sub array 1 is equal to 0. Initial index of sub array, this is the initial index of our first sub array. Now our index of sub array 2, it will also be equal to 0. Now for the index of our merged array, which is equal to the left now our while loop. Now I will write our while loop code for the merge of temporary arrays back into our left and right arrays. While index of sub array 1 is less than sub array 1, and index of our sub array 2 is less than our sub array 2. Now inside of this while loop I will check if the left array's index is less than or equal to the right array's index. Our left array and then index of our sub array 1 is less than or equal to our right array, and then index of sub array 2. So if this condition is true, then index of merged array will be equal to left array than the index of sub array 1. and then our increment code of index of subarray 1 will be increment by 1. And now here comes part of our else. If left array is not less than or equal to the right array, index of our merged array will be equal to the right subarray 2. And now our increment for the index of subarray 2 will be 1. It will be incremented by 1. Now I will write the while loop for copying the remaining element of left if there is any. And we have index of subarray 1. We will check if the index of subarray 1 is less than our subarray 1. If it is, then simply the array at the index of merge array will be equal to the left array at the index of subarray 1. Index for subarray 1. Now the while loop for copying the remaining element of our right array if there are available. Index of subarray 2 is less than subarray 2. Index of merge array will be equal to our right array at the index of right subarray 2. Then the increment index of subarray 2 by 1 and index of merge sort by 1. Now here comes our code for deleting these temporary subarrays, the temporary left array, then the deletion of our temporary right array. So our code for merge algorithm or the merge function is complete. Let me just make it small. You can see all of our code. So here is our code for the merge algorithm. Now I will write our code for printing the array. the code for our main driver code. We will first initialize an array of integer and give it values of, let's say, 12, 11, 13, 5, 6, 7. Now we'll call our print array function and give it our array and our array size, and then we will call our merge sort function and we'll give it our array at beginning, then the array size and array size -1, the end index. Then we will again call our print array function and we'll give it our array and array size. So our program is completed. Now let's try to run it and check if our array is sorting using merge sort or not. So let's try to run it. We are having an error. So what's the error? Oh yeah, I forgot to put semicolon at the end of it. So let's run it again. So you can see our array before the sorting was 12, 11, 13, 5, 6, 7, and after implementing the merge sort function on our array is now 5, 6, 7, 11, 12 and 13. So this is a successful execution for the program which we write for our merge sort algorithm. So now let's take a look at the time complexity of our merge sort algorithm. So the time complexity for merge sort algorithm is omega into n log into n. So sorting array on different machines, merge sort is recursive algorithm and the time complexity can be expressed as follow. For t of n is equal to 2t into n by 2 plus theta n. So the above recursion can be solved either using recursions or tree method or the master method. It fall in the case 2 of master method, and the solution of recurrence is theta n log n. So the time complexity of merge sort is theta n log n. In all three cases, worst, average and best. As merge sort always divide the array into two halves, it takes linear time to merge two halves. And the space complexity is omega n. In merge sort, all the elements are copied into auxiliary array, so an auxiliary space is required for the merge sort. So is merge sort in place? No, merge sort in merge sort the merging step requires extra space to store the element. So second question will be, is merge sort stable? So yes, it is stable. So that's all from today's video. Hope you like our video and don't forget to like, share and subscribe our channel. Hello guys, and welcome back to my YouTube channel. In our previous video we start the topic of merge sort algorithm, we see how we can implement merge sort algorithms, and then take a look at actual algorithm which we then later use to implement merge sort algorithm in C++. We successfully created our function of merge sort, and then we start to build our merge function. So now I will continue this video where I left our last video, or ends our last video. So we have create our first loop for copying data of temp arrays, left and right array, temporary array. Now first loop is created. Now I will create our second loop for auto I is equal auto j is equal to 0 and j is less than sub array 2, and then j plus plus. Now for the right temporary array, jth index is equal to array mid plus 1 plus j. Now for the index of sub array 1 is equal to 0. Initial index of sub array, this is the initial index of our first sub array. Now our index of subarray 2, it will also be equal to 0. Now for the index of our merged array, which is equal to the left now our while loop. Now I will write our while loop code for the merge of temporary arrays back into our left and right arrays. While index of subarray 1 is less than subarray 1, and index of our subarray 2 is less than our subarray 2. Now inside of this while loop, I will check if the left array's index is less than or equal to the right array's index. Our left array and then index of our subarray 1 is less than or equal to our right array, and then index of subarray 2. So if this condition is true, then index of merged array will be equal to left array, then the index of subarray 1. And then our increment code of index of subarray 1 will be increment by 1. And now here comes part of our else. If left array is not less than or equal to the right array, index of our merged array will be equal to the right subarray 2. And now our increment for the index of subarray 2 will be 1. It will be incremented by 1. Now I will write the while loop for copying the remaining element of left if there is any. And we have index of subarray 1. We'll check if the index of subarray 1 is less than our subarray 1. If it is, then simply the array at the index of merge array will be equal to the left array at the index of subarray 1. Index for subarray 1. Now the while loop for copying the remaining element of our right array if there are available. Index of subarray 2 is less than subarray 2. Index of merge array will be equal to our right array at the index of right subarray 2. Then the increment index of subarray 2 by 1 and index of merge sort by 1. Now here comes our code for deleting these temporary subarrays, the temporary left array, then the deletion of our temporary right array. So our code for merge algorithm or the merge function is complete. Let me just make it small. You can see all of our code. So here is our code for the merge algorithm. Now I will write our code for printing the array Now the code for our main driver code, we will first initialize an array of integer and give it values of, let's say, 12, 11, 13, 5, 6, 7. Now we'll call our print array function and give it our array and our array size, and then we will call our merge sort function and we'll give it our array at beginning, then the array size and array size -1, the end index. Then we will again call our print array function and we'll give it our array and array size. So our program is completed. Now let's try to run it and check if our array is sorting using merge sort or not. So let's try to run it. So we have having an error. So what's the error? Oh yeah, I forget to put semicolon at the end of it. So let's run it again. So you can see our array before the sorting was 12, 11, 13, 5, 6, 7, and after implementing the merge sort function on our array is now 5, 6, 7, 11, 12 and 13. So this is a successful execution for the program which we write for our merge sort algorithm. So now let's take a look at the time complexity of our merge sort algorithm. So the time complexity for merge sort algorithm is omega into n log into n. So sorting array on different machines, merge sort is a recursive algorithm and the time complexity can be expressed as follow. For t of n is equal to 2t into n by 2 plus theta n. So the above recursion can be solved either using recursions or tree method or the master method. It falls in the case 2 of master method, and the solution of recurrence is theta n log n. So the time complexity of merge sort is theta n log n. In all three cases, worst, average and best. As merge sort always divide the array into two halves, it takes linear time to merge two halves. And the space complexity is omega n. In merge sort, all the elements are copied into auxiliary array, so n auxiliary space is required for the merge sort. So is merge sort in place? No, merge sort in merge sort the merging step requires extra space to store the element. So second question will be, is merge sort stable? So yes, it is stable. So that's all from today's video. Hope you like our video and don't forget to like, share and subscribe our channel. Hello guys and welcome to my YouTube channel. In this video we will discuss the array sorting algorithms, and our first algorithm will be the selection sort algorithm. So let's see some definition of selection sort algorithm and see how it's actually work. The selection sort algorithm sort an array by repeating finding the minimum element. For example, consider an ascending order for the unsorted part and putting it at the beginning. The algorithm maintains two subarrays in a given array. Our first one is the subarray which already sorted, and second one is the remaining subarray was unsorted. In every iteration of selection sort, the minimum element, consider we are sorting it in ascending order, from the unsorted subarray is picked and moved to the sorted subarray. Now let's take a look at the flow chart of our selection sort. So here we have our flow chart of how the sorting array actually works. So we start our selection sort program. It will then read the length of array in this n and the array in ARR. Then it will set the I to the 0. So we are actually using a loop here, and then it will check if I is less than the 1 minus the total length of array. So if it is less than 1 minus n minus 1, then it will set the minimum index to I, and then will set the our nested loops j. So it is actually a nested loop. Then it will set the j of inner loop to I plus 1. Then it will check if j is less than n or not. So if j is less than n, then it will check if the jth index of array is less than the minimum index of array, and then it will initialize the minimum index to j, and then it will increment the j. Then this loop will keep going on until our j is greater than n. So in case of j is greater than n, it will simply pass the control to this swap method. Let me just make it bigger. Yes, so it will pass the control to this swap method, and after each swap our I will be increased, and then our loop control will return back to the parent loop here. Then it will keep doing on this until our I is greater than n minus 1. So in that case, this nested loop will be terminated and our array will be printed and our code will be ended. So this is the flow chart of how the sorting algorithm work. So now let's see an example of how the selection sort actually work. So let's consider we have an array of 5 having values 64, 25, 12, 22 and 11. Then in first pass, for the first position in sorted array, the whole array is traversed from index 0 to 4 sequentially, and the first position where 64 is stored is presently after traversing the whole array, it is clear that 11 is the lowest. So this 11 is the lowest from all of the array. Then thus we will replace this 11 at fourth index with this 64 which is present at our first index. So thus we replace 64 with 11. After one iteration, 11 which happened to be least value in the array tend to appear in the first position of this sorted list. Now in the second pass, where 25 is present, again we will traverse the rest of the array in a sequential manner. After traversing, we found that 12 is the second lowest value in our array and it should be appear at the second place in the array. Thus we will swap this value 2. So we will swap this 25 with the 12. In the third pass, we will again iterate the loop from 25 to 64, and in this iteration we will find out that 22 is the third lowest. Thus we will replace it with 25. Then the fourth pass, similarly fourth pass position traverse the rest of the array and find the fourth least element in the array. As 25 is the fourth lowest value, hence it will place at the fourth position here. Now at the fifth pass, the last and the largest value present in the array automatically get placed at the last position in the array. The resulted array will be something like that: 11, 12, 22, 25 and 64. So you can see we have sorted this array in an ascending order using the selection sort algorithm approach. Now we will see the C++ code and we'll implement this selection sort algorithm in our code editor. First I will write our swap function. It will accept two pointer type integer. First one will be the xp and second one will be our yp. Now inside of this swap function we will create a temporary integer and we will initialize it to the xp parameter. Then we will simply swap the xp with yp and then yp with our temp. So here our swapping is done, and as we are using these pointer, we are accessing these argument by their reference, so it will actually change their values. Next will be our selection sort function. It will accept two integers. First one will be the array which we have to sort, and second one will be the size of array. Now inside of this sort I will define three integer I and j for the loops and the min index. We will be using a nested loop inside this selection sort function. So let's start our first loop. I will be using for loop and we'll run this parent loop until the total until we reach all the indexes in our array. So I will put n-1 in this condition, and will be an increment of 1 after each successful iteration. Now we have to find the minimum element in our unsorted array. So I will just initialize the min index to the to our current value of I, which will also be our current index of the array. And next we will call our nested for loop for j is equal to I plus 1 and j is less than to the total length of our array, and we will increment j by 1, inside of which we will check if the array jth index of our array, which will be our second index for the first iteration, is less than our minth index, which is actually our 0th index, mean the first element of our array. So it will check if the jth or second index of array is less than the first index, which in this case is min index. Then in this case it will initialize the mean. If it is less than our minth index, then it will simply initialize the minth index to that index, which is j. Now we will again check if the minth index is not equal to I, which is our 0th index. In this case we will simply call our swap function and will pass the reference of our array min index, and at second we will pass the reference of array with the ith index. Sorry, I have to use this AND operator here. So yeah, we are good to go. Now the function for the printing of our sorted array, it will accept an array and the length of our array. We'll simply use the for loop for the printing purposes, and I is less than the size, or we can say n, I plus plus. So our printing function is also ready. Now let's create an array. The value will be same as we see in the example, 25, 12, 22 and 11. Then our size will be 1, 2, 3, 4 and 5. Then we call our selection sort and pass our array and the n. Then simply see out our message of sorted array, and then simply call our print array function to pass the array and our value. So let's run this program. So you can see our array is now sorted. So this is a successful execution of our program. So in next video we will see the time and space complexity for our selection sort algorithm. Hello guys, and welcome back to my YouTube channel. In our previous video we saw some definition of bubble sort, and then we implement bubble sort using C++. Now in this tutorial we will discuss insertion sort. We will see what is insertion sort and algorithm for insertion sort, and then we will implement it using C++. So insertion sort is a simple sorting algorithm that works similar to the way you sort playing cards in your hand. The array is virtually split into a sorted and unsorted part. Values from the unsorted part are picked and placed in the correct position of sorted part. So now let's see what are the characteristics of insertion sort. This algorithm is one of the simplest algorithm with simple implementation. Basically, insertion sort is efficient for small data values. Insertion sort is adaptive in nature. It is appropriate for data set which are already partially sorted. So now let's take a look at the working of insertion sort algorithm. Let's consider an example of an array having value 12, 11, 13, 5 and 6. Now in the first pass or the first iteration, initially first two elements of the array are compared in insertion sort. Here 12 is greater than 11, hence they are not in the ascending order, and 12 is not at its correct position. Then we will swap 11 with 12. So for now 11 is sorted in sorted subarray. Now in second pass we move to the next two elements and compare them. Here we will compare 12 and 13. Hence 13 is greater than 12. Thus both elements seem to be ascending order, hence no swapping will occur. 12 also sorted in the sorted subarray along with 11. Now in the third pass we will compare these two and swap them, and both 5 and 13 are not presented at their correct places, so we will swap them, and then we will compare these 13 and 6 and also swap them. After swapping element 12 and 5 are not sorted, thus we will swap them again. So we will swap 5 and 12. Here again 11 and 5 are not sorted, so we will swap them too. We will swap 11 and 5. This looks similar to the bubble sort, but there is a little bit difference between bubble sort and insertion sort. We will see it in a second. So here it is at its correct position. Now in fourth pass, now the element which are present in the sorted subarray 5, 11 and 12 move to the next two element 13 and 6. Now clearly they are not sorted, thus we perform swap between them. Now 6 is smaller than 12, hence we will swap them, and here is finally our completed sorted array. Now let's take a look at the algorithm of insertion sort. To sort an array of size n in an ascending order, we will iterate from the first index to the nth index over the array. We compare the current element key to its predecessor. If the key element is smaller than the predecessor, then we will compare it to the element before. Move the greater element in one position up to the make space for the swap element. Now we will see the implementation of insertion sort inside our VU Studio Code using C++. Here I will type our insertion sort function. It will be a void insertion sort. It will accept two arguments. First one is an array and second one is the size of array. Now I will make three variable I and j for the loops and key for the insertion sort algorithm. Now here we will initialize the key to the ith index of our array. For the first iteration it will be 1 and j to the I minus 1. Now move the elements of array that are greater than key to one position ahead of their current position. So for that we will use our child loop, but this time I will be using a while loop. Condition will be j greater than equal to 0 and jth index of our array is greater than the key. J plus 1 is equal to jth index of our array and j is equal to j minus 1 and then our j plus 1 index for array is equal to the key. So our function for the insertion sort algorithm is ready. Now I will write the function for inting the array. Void print array, it will accept an array of integer type and size of the array. Less than and I plus plus. So our print function is ready. Now let's move to our main driver code. We'll put the values, let's say 12, 11, 13, 5 and 6. Now the size of our array is size of our array divided by the size of our array 0th index. Now I will call our insertion sort function and will pass it the array and our size of array. Then I will simply print this array. So our complete code for the insertion sort algorithm is now ready. So let's try to run this in our terminal. So you can see it has sorted our array using the insertion sort algorithm. Now let's take a look at some time complexity or space complexity of our insertion sort algorithm. The time complexity of our insertion sort algorithm is omega n square, and the space complexity of our insertion sort algorithm is omega 1. So what are the boundary cases of insertion sort algorithm? Insertion sort takes maximum time to sort if the elements are sorted in reverse order, and it takes minimum time order of n when the elements are already sorted. So what are the algorithmic paradigm of insertion sort algorithm? Insertion sort algorithm follows the incremental approach. And next interview question can be, is insertion sort an in-place sorting algorithm? So yes, insertion sort is indeed an in-place sorting algorithm. Next, is insertion sort is a stable algorithm? Yes, insertion sort is a stable algorithm. So next, when is the insertion sort algorithm is used? Insertion sort is used when number of element is small, and it can also be useful when input array is almost sorted, only a few elements are misplaced in complete big array. Next, when is the insertion sort algorithm is used? So we have answered this question, and next we have, what is the binary insertion sort? So we can use binary search to reduce the number of comparison in normal insertion sort. Binary insertion sort use binary search to find the proper location to insert the selected item at each iteration. It is normal insertion. Sorting takes omega I at the ith iteration. In the worst case, we can reduce it by omega log I. by using a binary search. The algorithm as a whole still has a running worst case running time of omega n square, because the series of swap required for each insertion. Refer this for implementation. Next, how to implement insertion sort for linked list. So how we can implement insertion sort for linked list? So here is the insertion sort algorithm for linked list. First we will create an empty sorted or result list. Then we traverse the given list. Do following for every node. We will insert current node in the sorted way in the sorted or result list. Next we change the head of given linked list to the head of sorted or our result list. So that's all from our today's tutorial. In this video we see what are the insertion sort and what is the algorithm for implementing insertion sort. Then we implement the insertion sort using C++. We make this insertion sort function and then create nested loops, and then we run our program and have a successful execution, and our array was sorted in ascending order. Then we see the time complexity and space complexity of our insertion sort algorithm, and at the last we saw some interview question related to insertion sort. So that's all from today's video. Thanks for watching.